So welcome to next lecture of numerical problems in self-induced EMF. This is second set. An iron rod 20 centimeter long and 2 centimeter diameter is bent into a closed circular ring. A rod is bent into a closed circular ring and is uniformly wound with 3,000 turns of air. When a current of 0.5 ampere is passed through the coil, flux density in the iron rod is found to be 1.2 Tesla. Calculate permeability of iron, relative permeability of iron, inductance of coil, and the last one is voltage that would be induced in the coil if current is interrupted so that the flux in iron rod falls to 10 volt of its former value in 0.01 second. Here flux will be changing. So this is the iron rod. This iron rod of length, this is the length of iron rod 20 centimeter and 2 centimeters diameter, bent into a closed ring and is uniformly wound with 300 turns of wire. The wire is wound over it, 300 turns. When a current of 0.5 ampere is passed through the coil. So what are the given data still here? Length 0.2 meter, diameter 2 centimeter, that is 2 into 10 raised to minus 2 meter. Diameter means radius is given, and number of turns 3000. Current is given 0.5 ampere. Flux density B, flux density is given 1.2 Tesla. First parameter is to find the permeability. How will you find the permeability? Permeability is given by mu B by H. This is the equation for permeability, mu by H. Okay. What is B? 1.2 Tesla. How will you find H? What is the equation relating H and this given data? Yes, H equal to Ni by L. You can use that data. N number of turns, I current, length 20 centimeter, 0.2 meter. So we will be getting 7500 ampere turns. So how will you find mu? Mu equal to B by H. B is known value, H is also found out. So mu is 1.6 into 10 raised to minus 4. So you got the first part, permeability of iron. The second part is relative permeability. What is relative permeability? Mu R equal to mu by mu 0. We know that mu total permeability is mu 0 mu R. So relative permeability is mu by mu 0. Mu this value. Mu 0 is 4.10 raised to 7 minus 7. So you will be getting mu R 127. What is the next parameter? Inductance of the coil. What is the equation for L? Since flux is not given, instead the given data are length, area and everything. So you can use which equation? L equal to N5 by I. L equal to N5 by I. So flux is not given. Instead area and flux density is given. So flux is flux density into area. Area is pi r square. Pi into 10 raised to minus 4 meter square. We know that radius we found out as 1 into 10 raised to minus 2 meter. So phi equal to area into flux density, that is pi r square. This is the area value. Substitute the value of L. N into phi is AB by I. Number of turns into area into flux density by current is 0.5. So 2.26 Henry is the value of inductance. Next, the last parameter, EMF induced if the current is interrupted so that flux falls to 10 volt of its former value in 0.01 second. This is not volt. I think there is a correction. This is Weber. Flux in the iron rod, unit is Weber, falls to 10 Weber of its former value in 0.01 second. So equation for EMF induced is E equal to d5 by dt. Correction is 10%. 10% of formal value. This is the correct question. Voltage induced in the coil if current is interrupted so that the flux in iron rod falls to 10% of its former value. So initial flux, let it be 5. So flux fall to 10% of former value means 5 to become 5 minus this 10% of 5, that is 0.15, reduces to 0.15. So what is the final flux? 0.95. So the flux fall to 10% of former value. So what is d5? Phi1 minus phi2, that is 5 minus 10% means 0.15. So 0.95 is change in flux. What is the EMF? E equal to N into d5 by dt, that is N into 0.95 by dt. N into 0.9 into what is flux? B, flux density into area. So flux density 1.2, area pi r square by dt. dt is given as 0.01 second. Here it is given 0.01 second. So the value of EMF induced is 101.78 volt. So here is the next question. Iron ring of 30 cm diameter is made of a square of iron of 2 cm by 2 cm cross section and is uniformly wound with 400 turns of wire of 2 mm square cross section. This is square. Calculate the value of self-inductance if mu r is given. This is very easy question. First you write the given data. Once you write the given data, you can easily find out the parameter. Iron ring 30 cm diameter. So diameter of the iron ring is 30 cm. This is iron ring. That is diameter is 30 cm. Diameter of iron ring means you can able to get the length of iron ring. 2 pi r is 30 cm. 2 pi r. Using this equation you can find the length of iron ring. If the diameter of iron ring is given means you can find the length, because this is the diameter of this ring. If you expand this ring you will be getting the length. What is the equation for perimeter or length of a circular wire? 2 pi r, and 2r is given as 30 d diameter, that is 30 into 10 raised to minus 2, that is 0.3 pi. Next, the cross sectional area of the ring, that is this distance is 2 by 2 centimeter square, that is 4 centimeter square, 4 into 10 raised to minus 4 meter square. Then number of turns is given 400. Calculate the value of self-inductance of coil. So number of turns 400, mu r is given. What is the equation for L? Mu 0 mu r n square A by L. Mu 0 4.10 raised to minus 7, mu r 800, n number of turn 400 square, area is 4 into 10 raised to minus 4 meter square by length. Length is pi into d. This 0.3 into pi, that is 683.3 millihenry. So similar problems I have worked out. If you are having any doubt, you can contact me. These are all the same problem which we have already discussed, the same pattern. So kindly work out these problems. I have solved even 9 problems and one tutorial is there. So try to work out all these problems. So I will solve this 8th problem, discuss this 8th problem. There is a slight difference. Solenoid is wound with 1000 turns. So number of turns in the solenoid is 1000. So number of turn 1000, area 25 centimeter square. when a current 2.5 ampere flow through the coil, current is 2.5 ampere, flux density is 0.8 Weber per meter square when current is increased to when 2.5 ampere current flow through the coil, flux density is 0.8 Weber per meter square. That is when I equal to 2.5, let it be initial current I1 2.5, flux density B1 is 0.8 Weber per meter square. When current is increased to 5 ampere, I2 is 5 ampere, flux density become 1.2 Weber per meter square. Find the average value of self-inductance within given current limit. If change in current is achieved within 0.04 second, calculate self-induced EMF. We know inductance, write the given data first, then find the inductance cell N5 by I. We know that phi equal to area into flux density, because in your question flux density is given and area is given. So write in terms of area and flux density. So Na into dB, flux density is changing, area is constant. So we can write Na into B2 minus B1 by d5 by di, I2 minus I1. So number of turn 1000, area 0.0025, B2 is 1.2, B1 is 0.8, I2 is 5, I1 is 2.5. Substitute this value, will be getting 0.4 Henry. Once you got the inductance, EMF is calculated as L into di by dt. So try to do other problems also.